The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. We're going to get going here in just a few minutes. Thanks for logging in early as usual. Lots of early birds today for Dave for our understanding Wi-Fi standards and regulatory organizations.
Well, it's sure to be a thriller.
Chomping at the bit here. All right. I've got 10:57 here local time in Cleveland. Dave Hallis and I are both here at headquarters. And we're going to get going here in about 3 minutes. You guys know the drill. For those of you who have been to these events before, if you don't mind sending me a little note, letting me know where you're dialing in from, that'd be awesome. Give some shout outs here. I already see a lot of familiar names in the attendee list. So it's great seeing everyone back here each week. It means you guys love the content. We appreciate it. If you guys do have some suggestions for content, please message that over as well. And I'll give a shout out to those folks who recommend some content, and we'll get our engineers on it, and we'll create some content and some PowerPoints for you guys. So we're going to get started here in a few minutes. Again, thanks for joining us. I'm going to put you guys on mute, and I'm going to get myself ready here. Go ahead and use that Q&A pane to let me know where you're dialing in from and get some shout outs done. Be right back. All right, gang, I'm back. So thanks for those of you who dropped in your locations. I appreciate it. For those of you who haven't, you don't mind, let me know where you're dialing in from. That'd be awesome. I've got Vancouver, Philadelphia, Dallas, San Francisco, Sacramento, Boston, New York, Peoria, Illinois. We got Chicago, Illinois as well. Just a flat out Pennsylvania. Poughkeepsie, welcome. All right, nice, well-rounded group. For those of you who are too shy, I can understand. Not letting me know where you're dialing in from. That's cool. We're gonna go ahead and get started. I've got 11 a.m. local time here. Dave Hallis is with me today, and we're going to talk to you all about understanding Wi-Fi standards and regulatory organizations. So a real thriller today.
Yes,
Dave.
it's going to be very exciting.
Yes, very exciting stuff for you all. Thanks again for joining us. Again, I see a lot of familiar names in here. Week after week, we try and come up with excellent content for you all to learn from us and learn together. Our engineers here at Seven Signal are really best of class, and we're lucky to have them, whether that's Dave or Jim or Chris, Mike. We've got a lot of great talent over here. So as always, if you guys have other content you'd like to learn about, other topics you want to learn more about, send them my way, and we'll task some engineers with those topics and get them out to you. A lot of other folks messaged in. We got Oakhurst, we got Oxford, Ohio, we've got United Kingdom. Welcome, everyone. So we're going to go ahead and get started here. You guys know the drill. Before I get into about Seven Signal, Dave, why don't you tell us a little bit about yourself and why we should be listening to you today?
Sure. Right here at Seven Signal, I'm a solutions engineer, CWNA certified, and more than 25 years of wireless experience in product development, solutions engineering, and industry standards developments. At Cisco, I was recognized as a Cisco innovator. Obviously, I worked at Cisco that comments. If you're familiar with the AeroNet product line, that started off there, and then they were acquired by Cisco. I was also involved with standards. So I chaired 802.11i, which was for enhanced security.
So standards and regulation is near and dear to your heart.
That's right. So when the topic came up, I jumped at it.
Yeah, yes,
I get Jim out of the way. I was like, hey, get out of the way, Jim. And then more recently, 802.11i was published back in 2004. 802.11ah was more recent. That's for sub 1 gigahertz. That's more geared towards the Internet of Things. And then I was also involved in the formation of the Wi-Fi Alliance. Back then it was called WECA. Also before the Wi-Fi Alliance, there was testing at the University of New Hampshire. So I was going up there a bunch of times for introductory product testing with other companies. And then I've got a number of patents, 13.
Right on. You've been a busy man.
Oh, yeah.
All right, so let's get into a little bit about Seven Signal. Dave, welcome. Thanks for joining us today. Seven Signal started back in 2007. We crunch a lot of numbers here. So we analyze over 1 billion data points on a daily basis, over 200 customers, partners around the world, 12 patents to our name. So really the technology that you see from us, you'll only see from us. And we don't get into product demonstrations and alike on our Wednesday best practices webinars, but if you are interested in learning more about the products, reach out to me and I'd be happy to share that relevant information with you. We're homogenized in over 40 countries around the world. We're GDPR compliant. So for those of you, I know we had at least one UK person online today. For those of you who are concerned about data, we take that very, very seriously here, all the way through to GDPR compliance in the EU, and certainly adhere to other standards as well in the US and around the world. So we're here to enable the wireless world, and Seven Signal finds and fixes wireless issues. That's the what we do. So over the last several years, we've created an outside-in enterprise framework that's completely AP and device agnostic. We're completely independent and provide unadulterated data to our customers so they can find and fix issues, all completely modular. So depending on the issues or challenges that you're having within your organizations or in your customer organizations, for those of you who are MSPs on the line, we do tailor fit our solutions and services for those specific needs. All of our products are replete with reporting and analytics, as you would expect. And what we're doing is we're looking for the top 7 Wi-Fi problems. Everything in the world of Wi-Fi bubbles up to one of these 7 issues: congestion, coverage, co-channel and radio interference, network services, roaming, adapters and drivers, and wireless LAN. All of that stuff we're tracking in our software. Because what we're doing is we're running active and passive tests on the devices and on the network for things like packet loss, full spectrum analysis, looking at the adapter and driver combinations to see if they're acting appropriately, throughput, latency and jitters, MOS score for those of you running voice over IP devices. So really, really robust software. So it's important for you guys to understand the difference between outside in, which is Seven Signal, and that legacy approach. So for those of you who aren't customers on the line today, you're really looking at your vendor to provide information about your network and your wireless network, which is great. They can give you some really, really good data around top talkers and uptime and that kind of stuff, but they're not getting visibility into the end user experience because they're not monitoring what we are. We're complementary to your devices and your access points in your network. We live in the air, on the edge of the network, the last hop. The Seven Signal wireless ecosystem, again, is on that device, monitoring the access points, giving your engineers exactly what they need to identify poor roaming devices, other issues with the devices themselves, issues with the access points, looking for bugs in the APs, all kinds of issues. So we're getting that analysis to the engineers when they need it so they can get to the root cause of the issue. And because we can go back in time, there's no more, hey, I wasn't able to replicate that problem. Well, we're not experiencing that. No one else has complained about it. We can go back in time up to 90 days and look at that device and that network at that given time so we can can repeat that issue and see exactly what was going on at that time. So there's no more finger pointing back and forth between the device owners or the help desk and the engineers, the wireless engineers, the network engineers. We're giving you that root cause analysis that you just can't get from anywhere else. So in a nutshell, Seven Signal's got two modules that are part of our platform. MobileEye, which is the product that runs on the device, any Windows, Mac, or Android device. It's 100% software based, and it's looking for these 5 problems. You'll remember the problems from before. So that's looking at your adapters and drivers, looking for roaming issues, adjacent and co-channel interference, coverage, and congestion. While Sapphire Eye on the right is our sensor that lives up in the rafters with the access points or down on a desktop, mounted on a wall. It's a hardware and software subscription. It's got a full spectrum analyzer on that. So it's looking for things like network services, your configuration. Because it has that spectrum analyzer, it's able to look for interference, coverage, and congestion. So the differentiation between those two are in that boxed areas. So again, MobileEye is for those device issues. Sapphire Eye is more for the infrastructure. So with that said, didn't want to take up too much time, as I try not to each week. Dave, let's get on with the show.
Sounds good. First thing here is that what you might have seen is that I've been a standards delegate for some companies, and sometimes that you might be familiar with Wi-Fi, or you might even be familiar with 802.11. But exactly knowing where these standards kind of coming from, it might look like this, a big puzzle where you're trying to figure out, well, how do all these pieces kind of come together? This is where the point of this webinar is, to try to kind of give you an idea of how they sort of fit together and come together. Specifically, some of the ones that I'll be talking about are, I'm in the US, so I'll be more knowledgeable about the FCC. Obviously, that there's different regulatory agencies for different countries, and so therefore that they also kind of come into play. And then as far as IEEE, that's obviously that's where 802.11 is located. And there's some other ones that are in there, and as we talk through it, you'll be able to realize, oh yeah, of course, that there's some other ones that we're going to be interested in. And then there's the IETF, where there's a lot of standards that go on. That's kind of in the layer above. And then there's obviously there's the Wi-Fi Alliance. How does the Wi-Fi Alliance fit into all of this? So the place that I'd like to start is just in the US, the FCC. And that kind of gives us a base of where everything is going to go from here. So the important thing on this slide is that you'll see that this is part of the government. And they're going to set the rules. So therefore, before we're able to transmit, it's kind of very important to know, well, where can you transmit? What transmit power can you actually use? On this slide, you might have seen some of our other webinars. You might have seen some of this graphic. And so, well, where does the FCC come into place as far as on this graphic? On the bottom, where there's the frequencies, they kind of are telling us, okay, these are the frequencies that you're allowed to use. And when you're transmitting on here, what are the rules that are in place? For instance, what's the transmit power that you're able to use? Is this unlicensed or licensed? They'll dictate that. And then if you are using it, there might be other rules that are needed. For instance, we might be able to say that, oh, you have to do some radar detection. That would be indicated by the FCC. Now, as far as where exactly do these rules come out, kind of giving you an indication. Now, as far as the subchapters, those are kind of like places where to start, but you kind of go there. You kind of, if you were to Google search, Title 47, Part 15, .247, that'll take you to an idea of some of the rules for the.
Why on earth would you do something like that?
Well, if you're involved with standards and you're trying to manufacture something, then you say, oh, I know that this is how much I could actually transmit. And so that would be part of your design that you could kind of come up with.
All right.
But you could also, if you're designing something, you might be more interested in the Wi-Fi 802.11 standard. But those people that are actually creating the 802.11 standard, they have to kind of take this into account. Rulemaking at the FCC. So I kind of mentioned this is a government agency. Well, exactly how does this work? There's a bunch of acronyms in here. And so basically what ends up happening is the first part is that notice of inquiry. That gets sent out. This is kind of like, hey, this is kind of like an idea. This is what we're thinking about. And they'll get a bunch of comments back. And you could actually search for these, and I'll give you some links to some of them. I'm not going to give you the links to some of the comments that are entered in by different companies and different people, but you could actually go through it and search it. And then after getting these comments in, they'll take a look at it and say, okay, well, this is the most of the proposed rulemaking that we're going to make, and they'll kind of list that out, and they'll get into more details. And then again, that they could kind of go off and get a bunch of comments in and say, okay, well, somebody might be concerned about something. Obviously, if they're kind of changing some of the frequency allocations, there's going to be some people that are going to be affected. So, obviously, they're going to put in some comments about what their concerns are. One that the FCC is all ready and they think that, okay, this is basically where we're all set, then they'll put out a report in order and say, okay, this is basically where we're going. This is the new rules that we're going to go with. So I thought what I'd do is I'd take a topic that you might find interesting. You might have heard about 6 gigahertz band and what exactly is kind of going on there. That it's been termed right now to be Wi-Fi 6E. So there's Wi-Fi 6, which is for like the 82.11ax. And 6E is for extending that into the 6 gigahertz band. If you wanted to search for the NOI, that there's the link there, and that you'll be able to kind of take that and actually read what does it actually say. And then the NPRM, which kind of like came out afterwards, that after they received some comments, what were they actually proposing? And that'll kind of take you, and it'll give you an idea of where things, when it actually gets to the rules and order, that when we actually get those rules out, that they should kind of look something like that NPRM. Why is this kind of important? Why is the 6 gigahertz important? Well, you might have been attending one of our previous webinars on like channel utilization. And here what I'm trying to show here is that if you're doing something like AC and you said, hey, we were telling you don't run with 160 megahertz wide channels if you're in a carpeted office because you can't really create that many channels. Well, if you were to extend this out and go beyond going from 5 gigahertz going up to 6 gigahertz, now all of a sudden you do have a lot of channels that you could actually use for that 160 megahertz wide channels. And so having those additional channels makes it actually useful. So now that we got our base set as far as the FCC, kind of takes us into the IEEE, which is the Institute for Electrical and Electronics Engineering. So I'm a member of IEEE Si, which is where the standards get developed. And so what's their purpose? Basically to go off and create standards. What is that process? There's a lot more detail to this. There's the link at the bottom where I got this. And if Bruce Kramer's on the line, thanks, Bruce. Bruce was previous chair of 82.11, and he would usually give this at the beginning of some of the meetings, kind of describing how things get done. And there's documents that kind of get associated with all of this stuff. For instance, you might hear me say something about 82.11 has like a PAR. That's basically an IEEE term. And the PAR stands for the Project Authorization Request. And once you get it approved, that's where you can start doing work on a draft within a working group. Once you get that draft developed, you kind of go to sponsor ballot, where you're opening that up to a much larger group. Once you get that approved, then you can kind of go to the standards board, and you have to do some final approvals. Then you go off and you publish the standard. At the top, you might be looking at and say maximum of 4 years. Well, now wait a second, it takes you longer than 4 years to get done. So how does that work? While there is a maximum of 4 years, you got to go back and say, hey, I need more time. You can go back and say, okay, you get that PAR form extended. So IEEE itself has standards for a large number of things, and 802.802 is where it's the LAN man. So it's the networking area of standards. And that's got a lot of different areas where you're kind of going to be interested in. Some of them I kind of say, well, I mentioned here because you're going to be interested in them. And some I just kind of mention as, oh, by the way. For instance, 802.1, that I'll kind of give some examples of that and why you're interested in. Obviously, 802.3, that's Ethernet. Of course, even though we're wireless, we're still interested in that Ethernet wire. And then obviously 802.11 will be where I'll kind of spend a little bit more time. I just mentioned 802.15 as an informational purposes. This is where Bluetooth and Zigbee is kind of coming from. And then .16, WiMAX used to be in the news a lot. I did attend some of the meetings there as well. And that's actually entered into hibernation. No more new work is kind of going on. And then Radio Regulatory Technical Advisor Group. I didn't actually kind of get into it too much here, but as any type of kind of going to the FCC and trying to do some kind of put some comments in, that would you kind of filter through, and 802.11 would discuss with 802.18. The reason for that is because, as I mentioned, there's other wireless groups and they might have some other concerns as well. So my big point here is when I'm talking about 802.1 is that an access point is defined by more than just 802.11. And if you think about it, that all of a sudden becomes obvious as to why that is. That as far as bridging actually gets defined in 802.1d. And what do I mean by that? Well, when an access point gets a packet in on Ethernet, well, where does it actually send it? Does it send out over wireless, and vice versa when it gets something in on wireless? That's all covered by 802.1d. The reason I mentioned 802.1h is because it might not be apparent to you that, when you get something on Ethernet, then what's it look like when it goes out over 802.11? There has to be some mapping that kind of gets done, and that's described. 802.1h kind of brings it up, and then also it's mentioned in the Annex M of 802.11. 1Q, people are talking about SSIDs and VLANs, and then as far as .1P, that's for QoS markings that will line up with 802.11e for QoS. And then the one I'm very familiar with is 802.1x, because when I was chairing 802.11i, I was obviously discussing a lot of items with them as well, because I was coordinating that 802.1x usage in 802.11i. Ethernet, I'm not going to get into too much other than I say, obviously, access points have Ethernet on them commonly, and that you're obviously interested in power over Ethernet. So those power over Ethernet, if you're looking for where does that actually get standard, that's actually standardized in 802.3. So sometimes you might look at the specifications and it might say something like 802.3a AF. Well, that's kind of giving you an indication of where that standard is developed. Trivia note, as I mentioned, I was with Aeronet, which was acquired by Cisco. And one of the early access points that was 802.11 wasn't actually Ethernet. It was actually token ring. So it's just a trivia point. So getting on to 802.11. And here I'm just trying to give you a sense of, on the PHYs, the radio side of things, well, where were things started and how did they progress over time? The initial standard actually had 3 PHYs. By that, there's the direct sequence. This is kind of like the initial 802.11 2.4 radios. And then it kind of got improved with 802.11b, where we're able to kind of go up to 11 megabits per second on the radio. The other types were frequency hopping, and then infrared. I don't know of anybody that actually made an infrared, and frequency hopping. I don't know of anybody that's actually made it a frequency hopping, and I think that's actually out of the standard now. But then it rapidly kind of moved over to OFDM. That's where we kind of came up with 802.11a and G, and then through 802.11n and AC, it's been OFDM. Likewise, OFDM remains within AX, and then also kind of things are moving over to OFDMA with 802.11ax. Then some of the improvements there, you can kind of see it's always kind of want to go faster and faster and faster. 11ax doesn't want to, obviously wants to go faster, but it also wants to improve the efficiency. Some of the other radio types that are kind of that you might have heard about, AD was WiGig, so that's kind of going into the 60 gigahertz. television white spaces, that's 802.11af. And then my favorite, since I started this group, which was the 802.11ah. And the graphic on the right kind of gives you an idea. Why do you want to kind of go off and do some of those types of things? WiGig is like the distance is pretty short, but it does give you the capabilities for some very high data rates. And 11AH, the point there for Internet of Things was the data rate was low, but it goes much farther. So that was sort of the improvement there. And then getting into MAC amendments. So just a quick note is that when you're working on the radio side of things, when I'm talking about the PHY, the group that you're usually going to be wanting to coordinate and making sure that things line up is with the regulatory bodies, for instance, the FCC, making sure that, okay, we're planning on defining some radio. Does this fit within the requirements of the law and the rules? When it comes into some of the MAC amendments, most of those have to do with operational type of things. Here, as you might have remembered, that's with 5 gigahertz, that there's basically there were some bands that we could kind of operate, and then some we said, well, you could operate here, but you have to look out for if there's radar on the channel, and if there is radar, you have to get off. And so that had made us 802.11 say, well, how are we going to actually handle that? For instance, if you're on the channel, you want to tell the clients, hey, this is the channel that I'm going to go to. And that's what the purpose of 802.11ah was, is to kind of give that signaling to tell, and also for the transmit power control that kind of came in through 802.11ah. Most of the other MAC enhancements, they have to do with some, as I kind of mentioned here, kind of giving some examples, that you kind of want to do some type of coordination with some other standards bodies, but they're probably, it might not be the FCC per se, but some other groups. And why would you need to do that? Well, the reason why is, for instance, if you're doing a phone call, then 802.11e was to try to prioritize that. Now that prioritization is really on the airwaves, and you want that to actually be from end to end. For instance, I'm on the phone, one person, if it's on the wire, I need that to be prioritized as well. Likewise, if it's something like some of the security enhancements, well, if you're doing something beyond just like a pre-shared key, if you're doing like a enterprise type of security, you're probably going on and doing some type of interface with the radio server, and that kind of goes beyond just the 802.11 space. Some of the other MAC amendments, I just kind of mentioned them here, like mesh networking, that's kind of like coming out. There's a lot of products that are kind of coming out now. There's some proprietary ones, and then there's some standard-based one. If you're interested in the standards-based one, there's 802.11s. And then there's obviously some things for making that the connection a lot more stable. For instance, how busy are the airwaves? That's one of the things that we kind of got into, the channel utilization. To measure how busy the airwaves are, broadcast that so that clients can make more intelligent decisions. It goes beyond that as well, and there's a lot of things that in there to try to make that connection better. One of the issues that 802.11 also has is, as far as broadcast traffic and streaming some broadcast traffic out, that would not be as reliable, and there's some reasons for that, and that was recognized. And so 802.11aa was put in place to address some of those concerns. So the message here is that 802.11, besides trying to go faster, there's other things that need to be done to improve the system, the overall wireless experience. So I kind of mentioned, the IETF, and so you might say, well, some of you might say, I know what the IETF is, and if you don't know what it is, it's the Internet Engineering Task Force. This is kind of starting to make our puzzle a lot more
looking
complete.
Good, yeah.
Yeah, filling it up. I'll have to mention it to my wife. I actually have puzzle night every so often. I don't know if she'll want to do this puzzle, but
we guys combine puzzles, opera, and orchestra, right? Is that your world?
When we go out to the summertime and see the orchestra, we could take a puzzle along.
Yeah, we could, I guess. Yeah.
The mission statement of the IETF: make the internet work better. Now, the IETF standardization process. So I've been at the 802.1 meetings and 802.11 meetings, IETF meetings. I think it's just a general standpoint is that if they do operate a little bit differently, they're all for the same type of things, but they do operate, processes are a little bit different. If you attend the IETF a lot, you're probably not going to like going to IEEE. Likewise, if you go to IEEE meetings a lot, and you go to IETF, just because it being different, that you end up saying, well, this is I'm not you might not be as comfortable going to one versus another, and that just has to do with some of like IEEE is a little bit more formal as far as who could vote, who could comment on things. And then if you're used to going to things like 3GPP, you're like, well, both of your groups are kind of dumb. We like our process better. So what gets done in the IETF? So I'm hopefully that everybody knows what TCP/IP is. And so I just thought I'd mention that the RFCs that define TCP/IP. And it's like, oh, that's where it's at standardized. So actually, if you just Google search RFC 791, it'll pop up and you'll say, oh, this is what IP is. Now, why do I actually mention two? That's when things get updated, you'll see it on the RFC. It says updated or obsoleted by blah, blah. And so I kind of mentioned also like the last one. So then I mentioned, that 802.11i for enhanced security, which was the one that I kind of was the task group chair, that we were interested in some other things besides some IETF RFCs. For instance, you probably have heard about EAP, and I talked about 802.1x. Likewise, the type of authentication that you're done, there's a number of options that you can go with, but ETLS is a well-known one. And then you probably also heard about Radius. All those types of things are defined in RFCs. In that graphic, you might scratch your head and say, well, what exactly does that graphic mean? I'm familiar, if your users are familiar with using Wireshark to do look at packet captures, if you're looking at packet capture over the air, then what do you actually see? If first level is 802.11, and then you dig inside of that, and it's like, oh, that's a .1x packet, and then you dig within that, then you can see that's EAP. And if you dig within that further, then you'll see it's TLS. What does the access point do? It actually is communicating with a Radius server. That's the point of that is, and why, trying to give you a quick idea of why that's within this, you'd be interested in some of these other RFCs instead of just 802.11. I'm not trying to be thorough as kind of come up with the list, but just giving you an idea of some of them that you might also be interested in if you're involved with the wireless side. If you heard about CapWAP, yeah, there is an RFC there for CapWAP. And then likewise, if you were involved with the 802.11 AF experience with TV white spaces, TV white spaces, what the access point has to do is say, well, I'm in this given location. For this location, where can I operate? Which is different than like the DFS stuff. DFS is like the access point has to go off and detect if there's radar. Here, what ends up happening is the access point goes to a database and then says, I'm at this location, what channels can I use? Makes it a little bit easier. Why is that relevant here as well? It's just kind of like an interesting note as you start to take a look at the 6 gigahertz. That you'll hear some things about being able to talk to a database. So it's that same type of thing as instead of trying to do detect a different system out there, we'll just say, well, where you're located, and that's, for instance, in the 6 gigahertz band that the users, the licensed users, that there's a database that's set up of those users. So it's kind of easy to then look up in that location. Okay, this is what channels that have to be avoided. Now that's typically for in that area, outdoor usage. So we talked about the FCC, we talked about 802 and 802.11, and then the IETF, and that kind of takes us to the Wi-Fi Alliance. So if there's all those things kind of going on, why do you need the Wi-Fi Alliance? Well, the thing here is it brings everything together. It's not just going off and there's, as you kind of saw, that there were a number of different standards that are going on. And also not just that, but that you'll see that there's a lot of options. So what the Wi-Fi Alliance does is that it kind of goes off and it does a lot of collaboration between the members. And then also is promoting interoperability. So you go for compliance testing, you've got your product and say, well, does it actually work with other products? To do that, you'd obviously have to make sure you kind of like say, well, okay, this is what we're going to actually test for and the relevant standards that are involved. And it's also going to embrace technology and driving innovation and promoting that adoption. And then here we're kind of getting into this advocating for fair worldwide spectrum rules. And then so here, if you were to actually look for some of the comments that were put in for instance, on 6 gigahertz, what you'll see is that, oh, hey, there's actually some comments that came in from Wi-Fi Alliance. So the Wi-Fi Alliance puts in comments. Different companies can. As a person, you could just enter in comments. So there's kind of interesting to kind of look to see the comments of the different companies that put in. What are the different certifications that kind of go on? For instance, obviously, the AX is a big thing. So that you'll want to see that it's like Wi-Fi certified 6, which is where the AX is coming from. There's a lot of different certifications. I won't kind of go through them all. We were talking about 802.11i, and the latest is WPA 3. 802.11i, when it came out, well, led to the WPA and WPA 2. And it's good to see that, things have moved on. It's definitely needed to move on to WPA 3. Likewise, Miracast, if you're trying to stream some of your, like you've got a phone and you want to stream that off to a big screen. And then Easy Mesh, there's a number of products out there now that you can kind of come and put in Wi-Fi throughout the home and just have it all wireless. So kind of giving you a quick idea of all the different standards, and hopefully that gives you some insight into why there's a lot of different standards and why that it's kind of good to kind of have them all work together and hopefully put the puzzle all together and make it a little bit clearer for you.
Awesome. Well, thank you very much, Dave. Very thorough. So we'll take questions at this point. Hope you guys enjoyed the presentation. I always get these questions. I do see some of them coming through right now. Can we get a copy of the slides? Can we get a copy of the recording? Absolutely. We always share those, so we will continue to do that. All you need to do is email me. This is Don. You've all received emails from me. Simply reply to one of those. It'll come to me, and I'll get you to the right place. Let me start sifting through these questions here. First one is, how does the Wi-Fi Alliance decide which parts of 802.11 and 802.11 amendment get included into their certification?
A good question. It's basically by the members getting together, and there is a process that they will go through to say, okay, what parts of the spec are we going to actually certify? As I mentioned, there are a lot of times a lot of different options. Some of them get very technical as far as like beam forming. 11N came out. There are like a number of different options as far as aggregation, packet aggregation, and they'll kind of go off and say, okay, these are the exact things that we'll actually test for, and they'll build up test cases, and that has to do with the Wi-Fi Alliance members that actually attend and will vote on.
All right, very well. How about if someone's looking for more information on this topic, where would they go to find some stuff? I know we've got a wide audience on here, whether they're going after certifications and whatnot. Can you recommend any other resources besides the links in your presentation?
Yeah, I think I was kind of going the same place you were. It's kind of a very large topic, so it really kind of depends on where exactly you're trying to go. As far as like if you're interested in the IETF, well, then it's kind of easy at the IETF website. It's kind of
Sure.
an easy place to go to. And there, likewise, a lot of their discussions get done on mailing lists. So therefore, you're able to kind of follow how things are going just by joining a mailing list. ITripleE, that the voting that gets done at 802.11 does go by attendance. So obviously, if you're interested in that standards development, what you want to do is show up to a meeting.
Yeah.
There is a registration fee, but once you get beyond that, then it's the biggest thing is just if you're going to show up, it is more of an in-person type of thing versus the IETF, which is typically a lot of things done on the mailing lists. Wi-Fi Alliance, likewise, that's to attend to kind of show up to a Wi-Fi Alliance. That then you do have to kind of become a member. So there's different levels of membership. For instance, if you wanted to just say, well, I want to be able to get access to some of the marketing materials or some of the specs, I believe there's a membership for that. Versus, oh, I actually want to show up to some of the meetings. And then there's likewise another kind of a super category. It would be like the sponsor member. So.
All right. Well, thank you very much. I got a general question here about who we're partnered with, and I could take that in a lot of different directions. So, Paul, if you want to expand on that question, make sure I answer it directly. But I would like to give a plug for our partner CWNP. So I mentioned the certifications. We've been a partner with CWNP officially for almost 2 years now. All of these webinars that you folks attend are CWNP certified, so you can get a credit from CWNP, continuing education credit from them for attending here. All you need to do is shoot me an email, and I can send you over a certificate for that. Again, for continuing education credits. Really a great partnership. We're looking forward to their event coming up. I think we're sending 2 folks over to that WLPC event. Oh, excuse me. They're Wi-Fi track, so that's not till later in the year. But we always send folks to that event.
Now you didn't send me over to the Prague when they had a meeting.
Yeah, Prague we couldn't get you to, buddy. I'm sorry.
Oh man. Now if they set up a meeting in Hungary, let me know.
Right. So partner side again, to expand on that a little bit, we do have physical equipment partners, Zebra and SpectraLink and Honeywell, to name a few. So we do plug and play with those devices. We don't have official partners with access points. That's a little bit different for us. We do like to be independent. And since we're not installed on the access point like we are on the devices, we do like to remain independent there. So we're not officially partnered with a Cisco or Aruba or Extreme or anyone else. Though we certainly do monitor those access points, all of them actually. So hopefully that answers your question. If you have something more specific around partners, I'd be happy to answer that. We've probably got time for 1, maybe 2 questions here left. Here's the next one. What are the requirements being considered for Wi-Fi 6E, such as EIRP?
Oh, yeah. Yeah, good question. What you're going to find is that those are for the entire band. That will be a more complicated question, in that we'll have to wait for the rules in order to kind of come out. But if you look at the NPRM, that they actually do call that out. So if you are indoor, then that's, I believe it's at 14 dBm, and that would be able to operate across. So if you're indoor, that's fine. There are some rules as far as 6 gigahertz. That's you can't, like, I think when I looked at the NPRM, there were things like you can't use this in a car. Like, for instance, if you get some of the automobiles coming out that they have 8 to 11, that would not be allowed to be used there. As far as my reading of it, you'd not be able to use it. So it's basically something that's moving along in a train. That was the other thing that they called out. And you'd not be able to use it for communication with airplanes, that they actually called out. That I think they actually called out that, for instance, some of the planes have Wi-Fi in them for like local coverage. And so my reading of it would be that no, that you would not be able to go there. The reason why is because that there are some of these outdoor systems that are already there, and so you don't want to interfere with them. And then the database would then call out. And if you did say, I want to use it in a fixed location, then that's where you'd have to contact a database. I forget the exact term that they actually use, but it's basically a database that you say, hey, can I go off and use the bandwidth, the channel in this location? And that you could kind of use the higher power, provided that you're in a location that there isn't a licensed user at.
All right. Well, we're coming up on 40 minutes. We're actually at 40 minutes. So we like to keep these webinars to 30 to 40 minutes or so. Dave, thank you very much today. Great work. For those of you who would like to get into a product demo, as you know, we don't do product demos on these best practices webinars. We want to keep them more educational and informative. If you're interested and you want to take a quick product tour, no spin, no sales reps, you can go to go.sevensignal.com/tour. And we do have a webinar every Friday at noon, so a little lunch and learn for you. So if you're interested, go ahead to that link and we'll get you registered for that event. Don't forget the go dot, so sevensignal.com/tour will take you somewhere else. Make sure you get to the right spot. Any questions, please email me if we didn't get to your question, if I missed it in the chat room. I know that there was a couple others that came through. Email me and I'll get you the information that you need. Again, thanks to everyone for coming in today. Dave, thank you very much.
Sure. And as you're kind of going, if you're listening in on this and you said, some of the stuff was interesting. Some of this does get kind of nerdy, but this is actually my wheelhouse. So I kind of enjoyed it. But if you kind of looked at it and said, well, this is kind of interesting, Dave, but you didn't really get into the area that I was interested in, by all means, send Don an email and we'll see if we maybe another webinar.
Yeah, I'd love to do that. All right. Thanks, everybody. Have a great day. Rest of the week.